especially about this. Yeah.
Yeah. So under question three, um, I guess one of my questions was, for its solutions, like normally even in the shifting example one, you didn't really start at line one, you started at like line three, right? And in this time we started line four. I was wondering if you had any like I guess tips on how to, because for example your solution had like line four goes to line 18 or line four goes to line 24 depending on what it had to do, right? So
Yeah.
we actually skipped some of the lines.
Yeah.
I was wondering, like, um,
Yeah. Let's talk
yeah,
about that. That is a nuance. So let's go to um, steps for writing a Turing machine from Java code. All right. So I I wrote, this was written in regards to that very question you were talking about. Um, I added some extra notes about how to think about it. So let's see what it, right. Your task is given the machine, the Java pseudocode to write transition functions like this and fill out the whole table, right? And so this is the part you're talking about, is the first step is to choose which lines of code should be checkpoints. And what is a checkpoint in this case is when the Turing machine is going to pause and change states, right? So it doesn't have to, and as you asked, well, where the start state is, right? Because it sort of runs even before it gets to the start state. And the the ultimate answer to your question is that every time the Turing machine changes states, it can't execute further than moving the head twice, right? Because every time it takes a delta transition, it only can move the head once. So certainly every time the head is moved, then you need a checkpoint. The Turing machine needs to stop, change states, and move the head. Going the other direction, you could have it stop all the time when the head isn't being moved, in which case you would have the head and not move left or right, but stay where it is. And one thing that's a generally true thing is that given any Turing machine that has transitions where the head stays put, we could translate it into a slightly more optimal Turing machine that never uses the stay operation. Every time it transitions, it moves the head. So that's a rule of thumb, is you transition every time the head moves. Sometimes it's useful to have to help with the intuition of what's happening in this Turing machine. It sometimes has good intuition to have it not move the head when it's transitioning, and that breaks what the Turing machine is doing and down to the easier steps, so that maybe you can understand it better. All right. So the question is where to put these checkpoints so the first, I would say, if I give you a long piece of code with lots of lines in it, the first step is to know where to put those checkpoints. In fact, I just remembered that I'm going to be recording this and posting it on these slides, because these slides have never been shown before. I made them after the test, so I've never covered these slides, and we'll put the video on where these slides are. So we need to think about where the checkpoints should be. Now, you know that I'm also very religious about loop invariance, right? That the way to think about an algorithm is I'm at the top of the loop and I have a picture of what's true about my data structure when I'm at the top of the loop. And when I go around the loop, I need to maintain that picture, right? So one of the things that I give you is not only the code, but I will give you the loop invariant. So we can combine these two ideas that the first place to put a checkpoint is at the top of a loop. All right. Now, and the reason for that is because when you're writing the code, you want to say, okay, I'm in this state, and what do I know about the dynamic? What do I know about the Turing machine right at this point in the code, right? I need to know what state I'm in. I need to know what it's remembering. I need to know where it thinks the head is. I need to know where it thinks, what characters it thinks it's looking at. I need to know that before I can say what the Turing machine is going to do next. So the loop invariant that I'm giving you really spells out exactly what I want everything to look at, right? So you can just jump into the top of the loop invariant, say where the Turing machine is at, the whole configuration of the Turing machine, and then proceed from there each iteration, right? So there's one step in the algorithms course is from the precondition, how do you establish the loop invariant, right? And then the next step is from the loop invariant, how I go around back to the loop invariant, all right? And if we go back to the example that you asked about, right? This is the one we taught for. I gave a checkpoint, I'm pretty sure at line 4, right?
Yeah.
But I didn't give one at line 1, 2, and 3, right?
Yes.
And you might want to ask, why is that? Well, it's because I first said to myself, I said, Jeff, because I was talking to myself, I said, where do I want checkpoints? And I first thought I could have a checkpoint at line 3 because it's the top of the loop, right? And so what does the code do? It's at line 3, then it's at line 4. It goes around, it's at line 4, it goes around at line 4. It goes around line 4 a few times until it's finished the inner loop. And then it comes back up to line 3, right? Then it's at line 4 and it goes around line 4 a while until then it comes back up to line 3. And one thing I noted is that going from line 3 to line 4, the head doesn't move. I mean, one of the things about the head moving that the reason you need a checkpoint is partially because that's when the delta function moves the head, but partly a bigger issue is that when the head moves, then the Turing machine learns a character on the tape that it didn't know before, right? It memorizes on Pooh Bear's blackboard. It knows what state it's in, right? But it doesn't know the contents of the tape other than where the head is. And so it can keep moving as long as it has enough information. But when the head moves, it then learns something new about the tape, about life, right? It learns that the character at that cell, right? So going from line 3 to line 4, well, the head didn't move. I didn't learn anything, right? So I was figuring I could collapse, right? If you had a checkpoint at line 3 and a checkpoint at line 4, it's not like you would lose lots and lots of marks. Maybe I would take, if I was marking it, maybe I would take off 1 mark for style. But what would happen between line 3 and line 4 is the head wouldn't move. So it would be a stay. So you really could get from line 3 to line 4 without an extra transition. Now, why did I put the checkpoint at line 4, not at line 3? Is because we keep coming back to 4, right? I definitely need one at 4 because every time this inner loop happens, I come back to 4. And sometimes when I come back to 4, I'm not really coming back to 4. I go to 3 and then to 4, right? So how the computation happens, from 4, I go around the loop, come back to 4. From 4, I go around the loop, I come back to 4. And once in a while, I come up to 3 and come back to 4, right? But I work that in all into the transitions of the Turing machine simply from I'm at line 4 and I know it's true, right?
So I guess like a good checkpoint most of the time would be like where the loop is at, like at the beginning of the loop, or just when
Yeah,
the loop happens. So like
yeah. Yeah, so normally this is the first time, this problem was definitely harder than I've done before. It's the first time I've gave people homework, test question where there was a loop within a loop. So that is partly why I spent so much time during we had an hour and a half in which we went over this test question, and we in fact talked about checkpoints. And I don't remember, but I might have told them, hey, do we want a checkpoint here? Do we want a checkpoint here? And certainly my conclusion was a checkpoint here was good enough. We didn't need an extra one at 3 because from the 3 to 4, the head didn't move, right?
So I guess one of my questions now is at line 5, is that part of also like line 3 and 4 are loops?
Yeah.
Is that also part of the loop in line 4?
Well, line 5, I guess, is the first actual line that something is happening. And all right, well, let's have 2 questions. So this is Various code, right? So let's before we go on, let's go backwards. So the one question you might be asking is, from 4, where's my next checkpoint going to be, right? That's one question. And another question might be, well, where's my first checkpoint, right? Do I need a separate checkpoint? Where's my start state, right? And the reason the start state is where the Turing machine starts before it's looked at the input at all, right? The start state can't depend on what the input is. It needs to just start there and then start looking at the input, right? And if you look at the code that's running along here, right, what is the code doing? It allocates a variable, it assigns a value to the variable. It says, hey, I'm looping. And then it says I'm looping, right? It goes from one loop to another loop, right? Up until line 5 is the first place it looks at the input tape, right? So that's why I figured I could start right here, right? What will my start state be? Well, the start state is going to tell me I'm at line 4, right? The state always tells me what line I'm in. I'm in line 4. What variables do I have? Well, I have a variable p. What value does that variable p have? It has the value negative infinity. Where's the head? Well, that's not part of my state, right? So that my state just says that I'm at line 4 and I have a variable p whose value is negative 1,000 infinity, right? So
Yeah,
that's my start state. Does that make sense?
yeah, that totally makes sense. It was actually the line afterwards that kind of got me confused because the line after you had your start state was line 4. It was the same thing. It was line 4 and then p equals negative infinity. And then you said the input was blank. And then what got me confused was we didn't actually get our input until line 5. So when you said
Right.
line 4, input
All right.
blank.
So now let's think about how we get other checkpoints. All right, so I'm here, I'm having a checkpoint. And what I'm going to do is I'm going to know what state, based on the loop invariant, I'm going to say what state I'm in, right? And now when I'm in that state, I'm going to start running the code as long as I can run it. And I can run it up until when the head moves. And then when the head moves, I can't keep running because I can't keep running it without looking at what value the head reads. All right, so when can we run it till? Well, we can get the value of C because we're there. The C is the first character. If it's a blank, then I'm going to exit, right? If it's not a blank, I compare the value of P to the value of C. And all right, so here, actually, checkpoint here, if it's a blank, then I go somewhere else, I exit, right? So then what I'm going to do there is I'm going to go to a new state where it's the exit state, right? But if it's not a blank, I want to know, is P less than C? And if it is, then I move the head right. So I can keep going until I get here, right? And after there, then I panic, right? Or if it's other, I go to line 15 and then I panic. So from line 4 state, where I'm going to go to one of 3 places in one step. I'm either going to go to the exit place in one step, or I'm going to go right past this head move. And where does that take me? Right past the head move? It takes me here. It takes me maybe to line 18. I move the head, right? I move the head, but I don't, right? I want a checkpoint at line 18, right? Why do I want it at line 18? Well, because it's another loop, right? And the loop is a nice place to stop because I have a loop invariant that tells me what's happening at that loop, right? And so then the question is, can I get from line 4 to line 18 in one transition? And I think I can. Why? Because when do I go there? I go there if this is the case, then I'm going to move the head right. What I'm going to do, I'm going to change the value of P. So that helps me know how to change the state. And I know I'm going to move the head right. Can I keep going? Well, the reason I keep going is that I haven't used the value of the head. Maybe I should change this. I was saying you change states when the head moves, but that actually is a lie. The place you change states is when you use the value at the new location. You use the location that you just learned, right? So here I'm kind of reading the value where the head is, but I haven't used it yet. So I can get all the way to 18 without using it. Right? Does that make sense?
So you're basically saying, from our example, we started our loop, so we should have a checkpoint at where our loops start. And when we use any new information we got from the other initial checkpoints. So when we got information from line 5, that was still part of the loop from 4, right? So you can get there without actually having to move your head or whatever.
Or
and that's when you learn.
Use the information. Yeah.
Yeah. And then the new information we learned. So C, our next checkpoint would be when we use C, and that's at 18, right?
Yeah. Here I have various discussions about it, but let's leave this right now and see if we can go over to the answer and see what answer we give. Insertion sort. All right, so we're here. I'm going through the loop invariant, explaining the code, And we could go through that if people want, but let's go all the way down to just simply translating the code. So here's where I'm giving the start state, right? I come down here and this is where I'm going to start. I'm going to start saying I'm in line 4 and p equals negative infinity, right? Because that's kind of, nothing's really happened until then, right?
Yeah, that makes sense.
Nothing that depends on the input yet. This doesn't depend on the input. Does that make sense? All right, now we want to say, what does the loop invariant tell me? The loop invariant is going to tell me that I'm in line 4 and I have some value for p, some value, let's call it p prime is the value for p, right? And so, and I've already called, right? Was it q prime? What was q prime? It was I forget what q prime is, but if we read a blank, right? What do we say here? If c is the value at the head, so I'm reading the value at the head, and if it's a blank, then you want to exit the program, right? So where do I go? I go to all the way to line 34, which I assume is the end of this program, right? I could go to the halt state, right? Does that make sense?
Yeah.
And now,
So
yeah.
I was gonna say, I think that already answered my initial question. So it was why we, like for example, line 4 goes to line 34 instead of line 5 goes to line 34, but it's because our loop started at 4 and goes all the way down to line 14. So throughout line 4 to 14, that's our loop. So no matter what, our state would always be like line 4 to line 34 or like line 4 to line 18, despite the fact that we learned C at line 5, right?
Yeah, I can go until what happened, I learned something new, right? Here I know the value of C, right? The C here is either blank or not. So I'm assuming, I guess that maybe I'm lying a bit here because I'm assuming at line 4 I already know the value of C, right? So here at line 4, I'm saying I know the value where the head is. And then what happens? Well, I keep going with the code. In one case, I exit. So I come over here. And what's in another case? Well, here's a case. Suppose I'm in this state with some p prime, and I'm looking at some character c, and that c is bigger or equal to p prime, right? And I know this, right? I know what state I'm in, so I know the name of the state I'm in, and the state I'm in has the name with some value p prime. And I know what character I'm reading. I'm reading some C. So I can say, where do I go next? Well, I come into this code, I move my head right, right? So where am I going to go to again? Oh, yeah, sorry. I thought we were moving to the end, but you're right. We're coming back up to line 4, right? We didn't exit the loop, right? Here, I go from, I get down here and I move back up to line 4, right? Does that make sense? But what happens when I went around? Well, I did change the value of P. The value of P had been P prime. And when I go around, the value of P is now equal to C, right? So I did change the state in that regard. Does that make sense?
Yeah, no, that makes sense.
And I didn't change the value at the cell. So I was reading a cell and I read a C, I wrote a C. That's simply because I didn't change it. And I moved the head right. So I moved the head right. So what happens from 4 around to 4? Nothing but this, right?
Yeah.
The head moved once. I got some new information, which is the new value of C. That's all one loop, right?
Yeah, that makes sense.
Does that make sense? All right, so then we can
Yeah,
do
it
this.
does. Thank you, sir.
let's do a new case here when P prime happens to be bigger than C, right? What do we do there? We go to line 15, right? So here I said we could go to line 15, but look what happens at 15, nothing really, nothing really. We go over, right? We go to the head moves, but it doesn't for a while. Let's go to the top of the next loop, right? So we go to line 18 and right, this is saying I'm remembering. In fact, here's a funny thing, right? Here I'm remembering P, but line 15 tells me to forget the value of P, right? So I no longer know the value of P, and it tells me to remember the value Q. So I store, now I have a new value of Q. And what's Q? Q is the value that was at the head, right? Before I even moved the head. I haven't moved the head yet, right? So here, if I'm at line 4, and in these cases, then what do I do? As I change from state line 4 to line 18, I forget the value of P. I remember the value of Q, and the value of Q is whatever I was reading, the C value I was reading, right? And here I do have a stay, right? I told you you never needed a stay. But we did an awful lot of work so far. So let's not try to be too crazy. Let's have a transition here at 18. Does that make sense?
Yeah.
Anybody else have questions about this? Should we talk more about this?
Professor, can you hear me? Okay, if I see that you kind of, did we kind of skip? No, we didn't skip, but like we could have wrote 2 more steps, 2 more states, right? If we wanted, because we were on line, yes,
line 15, 16, 17.
Yes,
we could have, but nothing much would have happened, right? The head would have stayed. We wouldn't have learned anything new. Maybe we'd have had different states with one called line 4 and line 5, but it wouldn't have been very exciting.
Okay, all right, I got it.
So I kept running the program. I went from line 4 to line 8 because nothing really, in fact, the head never even does move. That's a stay there. I went from line 4 all the way to line 18 without the head moving and without learning any new information, right?
So let's say we did.
So,
Never mind.
do you want to talk first?
Nah, it's okay. I was asking a lot of questions before anyways, so you can go.
Oh, okay. What I wanted to ask was that, changing line is not significant information, and also this Q equals to C is not significant information. Is that what you're trying to say? So, it's the stuff outside that really counts.
Well, would you agree that what's true when I'm at line 4 is that I know I'm at line 4 and I have the value of P and I'm looking at some cell and I know the value of that cell, right?
Yes.
That's what's true at line 4. What's true at line 18? Well, I know I'm at line 18. I no longer know the value of P. I now know the value of Q. I now have a new variable Q. And what's the value of Q? It's whatever I'm looking at. The C I was looking at. The head hasn't moved yet, right? So I'm still looking at the same C, right? So I think people can agree that I was in this kind of world, and now I'm over here in this configuration, and I can get from here to here in one transition of the Turing machine. Right? So I guess my point is, if I can get there in one transition of the Turing machine, why shouldn't I? And if you had written it out, I'm in line 4 and then I'm in line 5, and then at some point you do a jump, right? Because there was an if and a go to, right? You could have written, and each time the head stays, right? And if you have a bunch of times where the head is, in fact, maybe that's another method is you just have a checkpoint at each line. And then if it feels like your head's not moving, try to collapse some of them into fewer transitions, right? Now here I have a head staying. Why did I have why do I have a checkpoint at line 18? Well, because it's the top of the loop, right? And I'm gonna want to keep coming back to the top of the loop. So that's why I put, even though I'm staying, I put a checkpoint at the top of the loop.
Sir, you mentioned that you could have written like states from line 4 to line 5 or line 5 to line 6. But
Yeah.
isn't it impossible to do that when line 4 to line 5, line 4 doesn't actually get any new input?
Yeah, well,
Or
you
like-
could have said, I'm in line 4, P equals P prime. I'm reading some value. Then I go to line 5, P equals P prime. I'm reading the same value and I stay, then I'm reading this, right? So you could have just had more states and you go from line 4 to line 5 to line 6 and nothing happens, right?
Oh, I thought since, oh wait, so line 4, even though it doesn't actually tell you to read an input value, you can still write down C? Because line 5 is when it actually tells you to read C.
Yeah. So here's the Turing machine, right? I'm in some state and I say, if I'm reading character 8 while I'm in this state, then go from state 5. If I'm in state 5 and I'm reading character 8, then go to 6, right? And then I'm in state 6. Well, I'm still reading the 8, right? Because I didn't move the head, right? So if I'm in 5 and I'm reading an 8, then it says write the 8 back and don't change states. All right, so now I'm in line 6 and I'm reading the same 8. So what do I do now? It says, well, the rules say if you're in line 6 and you're reading an 8, then don't have the character head move, so you're still reading the 8, and go over to state 9. All right, so now I'm in state 9, right? So I'm moving from state 5 to 6 to 7 to 8. Yeah, but so why am I doing that, right? Nothing's happening.
Yeah, and I guess,
So-
well, like one really quick, oh, sorry. So for like a really quick follow-up question, if you do write more states, then that would have been when you ask us to count all the states in our program, like our Turing machine program, for example.
Yeah.
We would have someone who wrote more states would have more states to write down, like maybe 3,000 instead of 300 or something.
Yeah.
You would mark both of them right? Like depending on how we wrote our Turing machine program.
If I was marking it, I can't always promise what the TA is going to do, right? I try to explain things to the TA, but hopefully the TA, the first question is write a Turing machine. And then the second question is, how many states are in your Turing machine, right?
Yeah.
So your answer is, even if your Turing machine is total garbage, right? The answer, the question, how many Turing machines are in your state, should be how many Turing machines are in your garbage Turing machine? How many states are in your garbage Turing machine, right? So,
Yeah, so even if my part A is, so
Yeah.
even if my part A is completely wrong, then
yeah. So what your answer for count should say is, well, look at how many values of P prime are there? Well, P prime is between their D plus 1 values for D prime, right? So I would say, how many states do I have? Well, I have D plus 1 states that are line 4, right? Now your answer will have to say, oh, I have a line 5. So I have D plus 1 states with their line 5, and you maybe have a line 6. So you have D plus 1 states that are line 6, right? You would say that. But my answer, I won't have a line 4 and a line 5 and a line 6. So I'll say I have D plus 1 states that are line 4. And then I'll skip over to, oh, look it, and I have C also has D plus 1 values, right? So I have D plus 1 states that are line 18. In fact, I think in my answer, I say all these lines, they all have D plus, I know I have 7 lines that have D plus 1 states. So that's 7 times D plus 1, right?
Yeah, that was your answer.
And you wouldn't have had 7 lines that are D plus 1. You'd have had 12 lines that had D plus 1. So your answer would have been 12 times D plus 1, and mine would have been 7 times D plus 1, right? But hopefully the TA is smart enough to read over to that. Right? In fact, if I was marking it, I wouldn't go back and look at your Turing machine. Your Turing machine might have been a few pages up. And if you told me I have 13 lines that have D plus 1 values for each of them, and so you multiplied 13 by D plus 1, I would say, I believe her, right? Sounds right. If you had said I only have 5 states, I would have said you're wrong, right? I have a sense of what's kind of a reasonable answer, and I'm not going to go nitpick. When I'm marking, I wouldn't nitpick. Oh, you forgot this one, right? I want a general feeling. Are you doing it? Do you have a sense of how many states there are?
Yeah,
right?
that makes sense. Thank you, sir.
In fact, the point of this, there's some discussion at the end where the point is that the number of states is some constant times D. And this whole, I have a whole discussion about I'm forgetting P and I'm remembering Q. That's so I make sure I'm never remembering P and Q at the same time, right? I'm very careful in my code never to remember P and Q at the same time. Why is that? If I remembered P and Q, how many states would I have? Right?
Yeah.
I would need D squared states, right? I would need D, there would be D choices for P and D choices for Q. So the number of states would be order D squared. Right? So some of the questions there are being extra careful to show, hey, look at, I'm wanting that the number of states you have is order D. And I think, in fact, if you just had said, hey, it's order D, I would probably be happy with that. And then in the next question, you say, hey, what happens if I remember both P and Q? Then you say, oh, then the number of states I have would have gone up to order D squared.
Professor, I remember in one question you also multiplied the lines to what X and Y, for example. So
Yeah.
here, wouldn't we multiply the number of lines too, while determining the number of states? Yeah.
So then you're counting the number of lines, are you?
Yeah, D squared times whatever line we like, how many line we have.
Right, right. So I'm saying here the number of states that have line 4 is D plus 1 because I have D plus 1 options here. And it could more or less be that in each of my lines, it's the same D plus 1. So then I would just say, oh, let's not worry about the details. More or less, each of my lines has D plus 1 options. I have 20 lines. So I'm going to just write down the answer 20, which is the number of lines, times D plus 1, which is the number of values of P prime, and call it done, right? And would that be perfect? Well, maybe somebody would say, oh no, because look at this state, it's your halt state, and it only has one option. But I'm like, okay, yeah, whatever, dude. Right? Now, I don't know. I think you should be as precise as possible because maybe the TA will be more nitpicky than I am. right? It's hard for me to tell how the TA how nitpicky to be.
Okay, and when we added d plus 1, by plus 1 we meant the halt state, right?
No, the D plus 1 is the infinity,
Oh, okay.
right? How many values can P prime be? D plus 1.
Okay, got it.
Right.
Okay.
And same here, C, right, is also D plus 1. Right? And why is the negative infinity there? It's because I made that very first, remember in the precondition, I don't know if you remember it, I said the very first character of your input is going to be negative infinity. And why did I do that? Well, it just made all the code a little easier. That negative infinity comes from the very first input, and you know that it's sorted because negative infinity comes first. Right? Does that make sense? So in this question, I would say that there are two hard things that I made you do. Well, the one hard thing is understanding this code and seeing why this Java-like code sorts, right? It's just running insertion sort. It's doing just your anything if you write insertion sort in any language, right? But the truth is, on a test, you don't actually even have to understand what my code does, right? You just have to translate it into Turing machine.
Professor, in the test, are we going to be asked if to translate from multi-tape Turing machine to single tape Turing machines?
Possibly.
Oh, okay.
Or possibly from a single tape to a multi-tape, or I could ask you anything. The sky's the limit. How you doing, Shahnaz?
Yes, sir. This is very interesting. Very interesting. I'm still confused about how many states. How do we? Maybe I'll go back. No, I don't have any questions. I just have to go back and.
Right. My reading is you look like, oh dear, I don't know what I'm doing. Rolling your eyes a bit.
Yeah.
I appreciate that.
Well, after this morning, I'm a little scared of you.
Oh, you're doing the 1092.
Yeah, I want you to be happy.
Yeah.
Yeah.
I don't want people afraid of me.
No, I'm just joking. No, you're a chill guy. We're not scared of you. No, it's just that this understanding this, I just don't want to make a mistake in how many states there are, Yeah.
Right.
Yeah.
Right. Well,
Otherwise it's okay, yeah.
can you count how many? So the easiest way to do it is for each line to say how many states are there that say line 4. And can you see why it's D plus 1?
Yeah, because it's right there, D plus 1.
Yeah. Now, what happens if I had line 4, P equals P prime and Q equals C? Do you know how many states there would be then with line 4?
It would be, no, how many would it be?
Well, how many values of P are there? D plus 1, right?
Yeah, P and D plus 1, yeah.
How many values of Q are there? D plus 1.
Right.
Right. So if I said line 4, P equals something, Q equals something, then they would be D plus 1 squared such states.
D plus 1 squared, yeah.
right? Because for each value, there are D plus 1 values of P and D plus 1 values of Q. And that gives me D plus 1 squared states.
Because of P and Q, right?
Because I'm remembering P and I'm remembering Q,
Yes.
right? Does that make sense?
Yeah, it does now.
So
Yeah.
they're D squared different things that I can remember, right?
Yeah.
Remember P equals 0, Q equals 0, P equals 0, Q equals 1, P equals 0, Q equals 2, right?
Right.
They're D squared of those.
Mhm. Because we have two variables now. Would we? Yeah.
Right?
Right.
If I was remembering 3 variables,
Then it would be cubed.
it would be D cubed,
Right.
right? Exactly.
Mhm. Yeah.
So if you want to be anal and count every little state, then that might take a little bit of math. But if you just want to sweep over and have the general idea,
Mhm.
say, which line do I remember the most variables, right? And then you
Yeah.
do that kind of multiplying. How many values of my first variable times how many values of my second variable times how many values of my third variable, right?
Mhm.
Then that tells me how many times how many states there are that say line 4, right? And since I
Right.
chose line 4 to be the one that is sort of the scariest, that remembers the most, then an upper bound on the number of states is you take the number of states for line 4 and multiply it by the number of lines, right? That's what somebody, I don't know whether it was, maybe it was Sammy or GI, somebody talked about multiplying by the number of lines, right?
Mhm.
That gives you a quick upper bound. And as a theorist, I would be happy enough with that, right?
Yeah.
The TA might not give you full marks because you didn't count each one. But
We got the idea. Yeah.
I would, if I was marking it, I would give you 99%.
Mhm.
And really, what I really want to know is, do you understand what a state is, right? Because by asking you how many states are there, it lets me know whether you're understanding what's really going on there. Because when I mark something wrong with a big 0, what if they answered? They've answered there's only one state with line 4, right?
Mhm.
That's showing me that they think they don't really understand what I mean by a state. Right? And that's ultimately what I'm trying to test them on.
I see.
Hello?
So you
Thank
guys are taking this test tomorrow morning, aren't you?
Yeah.
That's not fun.
Have mercy.
Well, it's too late now. It's made up.
Professor, are we going to have the test question session? Like the one, like I hope not like 1090, but like 1090.
Well, I'm pretty upset by it all. But you guys,
Professor, but that's
What
a
would make
different
you
course.
happy? Because the test review was so nice. It was like I understood the questions properly, you know. Me and
Yeah.
my partner I think we did a pretty okay job. So if we have I'm 100% sure most of us will have questions.
I know you will. I know you will. But let me tell you, I mean, I get so upset by these things. Let me tell
That's
you,
true.
last year, particularly in 1090, every test, people would say, is this the answer? And maybe it was because of that, or maybe because I gave 2 big hints. 60% of the people got an A. right? You give away the answers, then people are gonna get too many A's.
That's true. Yeah.
Department gets mad at me. York has one rule which says you're not allowed to give more than 30% A's. So I moved A's down from 60%. I think I still gave 40% A's. Right? So I'm fighting the university. And I get so many nasty emails. People are so mad that they said, I got an A, I deserved an A. Well, no, no, you can't all get A's. People were so upset with me. I got sick from how upset people were with me.
It's just that what do we do when we have a question after looking at the test? Like what do we do now? What do we do now?
Well,
That's the thing.
it's like people just could not learn. And, you know, in our meeting, somebody, if you were there, he
Yeah, I
said,
understand. Yeah.
is the answer that we're
Cases, yeah. It was he said cases, I remember.
by case,
Yes.
right?
Whoever's here, they were there too, I think, yeah.
Right?
Yeah.
Well, yeah, it's not a big answer. Surely everybody knew it was proved by cases.
Yeah, but that was very obvious. It was cases, yeah.
But then don't say it,
Yeah.
right?
Yeah,
Even there was a woman 20 minutes later who wanted to say, hey, look it, there are two models, and the one model is this is true, and the other model is that. She did it again,
yeah.
right? And surely I overreacted, but I really wanted to nail it. It's like, no, I mean, no,
Yeah.
right?
Yeah, that's true. No, what do we do?
Well, it's on Reddit. It's on YouTube.
Yeah, that's not nice. That's
Culture.
not nice of them. No.
What I would like is if whoever put it on Reddit and YouTube tries to take it down.
Yeah.
I don't know who did it. And you know how I found out about it?
How?
Boss emails me,
Oh my God.
right?
Yeah. No, for sure. Yeah.
Culture stuff works. Somebody's upset with you, or they're just amused.
Mm-hmm.
Start writing to people's bosses. How was that fun?
Oh, the person wasn't, somebody just wrote that the person wasn't from the class.
Well, then how did they?
Oh my God.
How did they know? From the
Yeah,
class?
obviously from someone in the class. So this is unfortunate. Very.
Yeah, I think it might have just been like the context, because if people knew like the context was the person who was talking was releasing answers for a test, then there would like a lot more students would understand why you were angry at the person who was talking.
Yeah.
I think the posts were just, oh, why is the professor doing this? And then the video. So there wasn't actually context. So
Right.
anyone who watched it didn't actually realize that it was a test.
Right.
Because he explained himself after, so there should be no worry about it.
Well,
He-
for sure, for sure. Anyway, I do know that you guys need to answer questions during the test. I know it. I give hard tests, right? And this morning, I was hoping that students were going to be extra nice to me because I was so grumpy. But no, what did students say this morning? They said, oh, your test is too hard. And they said, you didn't write your questions nicely. And you didn't tell me the answer to question 3, so I didn't know the answer to question 4. But guys, I don't think it was that hard of a test. In fact, I bet you the average, most people will get an A on it.
It's just like a puzzle. Like a test can't just be straightforward, right? So you kind of curved it, like, it was a little, but it was fine. Like it took some time. 24 hours was a good time, so it was good.
I do think people, I mean, I would make that test that during an hour and a half in the class, and people do what they do, and
Really, you would do the same test for hour and a half?
more or less.
Oh my God, that would be very difficult to do then.
Well, you would write something down.
Jeff, like I was just looking at the practice test we had up there.
Yeah.
Like compared to like the insertion sort, like the insertion sort question I found really hard. And
Yeah.
like, but like comparing it to like I did the practice test too, and the practice test was like pretty good. So like, would you say it's like somewhere between the two of them, or is it kind of more like the insertion sort kind of question?
Insertion sort was long.
Okay.
I would say I don't always know
Because like the practice test
No.
question,
how hard it's going to be for you.
yeah, but like the practice test question was like a palindrome, right? Like checking to see if like the last digit is the same and that back and forth. Would it kind of be something like that, or would it be something a little bit more complicated than that?
I would say tomorrow's test
Mhm.
is intellectually more challenging than anything we've done. And in terms of actual doing it,
Mhm.
easier than anything we've done.
Oh, so it's mainly going to be like if you get the loop invariant,
You
then you're
understand
okay.
it, it's
Yeah.
going to be easy. And if you don't understand it, you're going to die.
Okay, that's good to know.
And in fact, one advice I often give is if you're doing something hard, if you're giving some big, complicated, hard answer, then you're doing it wrong.
Okay.
Because one thing that people say about all my tests is that when they see the solution set, they say, yeah, that was easy.
Mhm.
So if you're writing a solution that looks crazy and hard, you're doing it wrong.
Okay. But like, is it going to be, but it's not going to be like the insertion sort where it's like 30 lines. It's probably going to be like 20-ish or like 10 to 15-ish lines, right?
You want me to tell you how many lines are in the pseudocode?
Sure.
You ready?
Yeah.
1.
Huh?
Okay.
That's scary.
Oh, that makes it really unique. Wow.
Yeah, that's that's a little bit scary.
That's what I'm saying. In some ways, Shahnaz, is that pretty good?
Yes, Shanaz, yeah.
Shahnaz is right? Somehow by having it one line makes it worse.
Yeah.
That's a lot of, that one line is packed with beauty.
Oh. So then it's probably better that I spend my time kind of like learning how to like the insertion sort problem works versus feeling confident on the palindrome here.
I don't know.
Okay. Yeah, sorry. I know that's kind of a subjective question.
I would say kind of what Mary was saying. The hard part of the palindrome exercise was knowing where to put the checkpoints.
Mhm.
Right? I think if I had told you there's a checkpoint at line 4, and then there's not another checkpoint until we come back to 4, or we go all the way to 18,
Mhm.
right? Then there are really so few checkpoints, right?
Mhm.
I don't know how many checkpoints did I have the palindrome have? It probably didn't have more than 4 or 5 of them, right?
Mhm.
So the number of lines of Turing code you needed to write was really pretty small.
No, yeah, it wasn't
Right?
too bad. Yeah.
So I think if I told you, okay, you're in state line 4 now, and what are you remembering in line 4? Okay, you could have gotten that. Okay, now keep writing until you get to line 18. What do you know that? I think it would have come so easily,
Mhm.
right?
Yeah.
Anybody who understands what we're doing here could have just written it down. That's my belief, though I could have been wrong, right?
Mhm.
And the hard thing then is to know to have a checkpoint at line 4 and a checkpoint at line 18, right? That
Yeah.
was the hard part. And let me tell you something else about this. We could go look because it's still up there, but I bet you the average was still 70 or 80%.
Yeah.
People did well on the test.
Mhm.
Now, is it because you had 24 hours? Is it because you're all copying from each other? Right? I don't know. I tell you one thing that's absolutely, absolutely for sure. Nobody got the answer from the Googling it.
Oh yeah.
You will not find my questions answers by Googling them,
Mhm.
right?
Yeah.
That we know,
Mhm.
right?
Yeah.
So was it too hard? I don't know. People did well on it.
Yeah, like with just all the lines of code, I kind of got a little bit lost. But like you said, once you figure it out, then it's not that bad. But
And you know, I in my hour and a half, I went over every line of the code and explained what the algorithm was doing.
yeah, that would have made it a lot easier than just
You
trying to
did,
read it
right?
yourself. Yeah.
And in the end, you don't even really need to know that. You don't need to know what the code's doing to translate it,
Mhm.
right?
And for like, do you have any like recommendations or kind of like hints, like really understanding where those checkpoints are?
Well, in
Um,
this case, can you tell me right now where the checkpoints are?
Kinda. I have to pull it up.
Small question. Which lines are the checkpoints are on?
Yeah.
Which ones?
Right now?
Yeah. What lines are the test tomorrow? Can you tell me where all the checkpoints are?
I can't tell you because I don't know the test tomorrow, right? But yeah,
Yeah. What do you know about the test?
it's one line. Oh,
One
so
line.
it's,
Where
yeah,
are the checkpoints?
it's all line one.
All line one, dude. All line one. Right? You know what I'm saying?
Yeah, as long as that's one of the questions, I'm good.
So I'll tell you where the checkpoints are right now.
Okay.
They're on line one,
Okay. I'll make sure to put that in my notes.
right?
No, but sir, seriously, like I don't mean to. Of course, this is a question where I'm asking, but I don't want it to be like asking. How would we know where the checkpoints are? Like, what is there any kind of clue, or no matter what you say, will give us the answer?
Well, see what's on the slide. I mean, I did write those notes trying to
Yeah.
say where they were on, right?
Yeah,
And
yeah.
what am I trying to say is definitely put them at the top of the loop. Right? Now,
Yeah.
it was a little scary because I didn't put one on top of, when there was a loop, I didn't put 2 checkpoints. So my definitely was sort of a lie there. And then you run it until you either get to a checkpoint or you need new information because the head moved, right? And then you need a new checkpoint. Right? That's the answer,
Mhm.
right? Now, do you need to know more than that? The answer is no. Why? Because tomorrow's test, I've told you where the checkpoints are, and then you'll never have to do Turing machines ever again in your life.
Oh, this is it.
This is it, dude. We're done Turing machines. You survive tomorrow, and we go on to finite state automata.
Is this ever going to help us in future? No, right?
Well, that's a very philosophical question.
Oh, you mean the theory part? It will kind of it does link to, of course.
I'll tell you what so for years I said I thought this whole course was too abstract and wasn't useful for it. You know, I was teaching it and students were like, why are we doing this? Right? And I do think that I've made it, I've tried to emphasize what I think is important. And what do I think that you should learn? What is the take home that Jeff is trying to get you to know about Turing machines? The first thing is it is useful to learn how to think abstractly, right? It's just a skill to be able to think abstractly. And in terms of computation, one way to think about computation is it's a sequence of actions, but another way of thinking about it, computation is it's a sequence of checkpoints. I'm here. What do I know when I'm here? That tells me what state I'm in, right? And then
Yes.
based on what state I am in, what do I know? What do I learn next? And then what state will I be in next?
Yeah, it's a bunch of loop invariants and
Thinking about computation as moving from one state to another state to another state as you gain information about the world, I think is an abstraction that will help you in your careers as computer scientists. That I do think is true. And if you're going to be a computer scientist and you don't know what a Turing machine is, then that would be sort of an embarrassment too, right? It's kind of like being an artist and not knowing
Picasso.
Picasso, right?
Yeah.
Right? You need to know what the forefathers did, right?
Yeah. Yeah.
So that's what I'm going to say, right? And now you have the idea of moving from state to state. The next topic is finite state automatas. And it's basically, when I said that we were done with Turing machines, basically, I'm somewhat lying, because what is a finite state automata is it's a Turing machine without a tape. So you remove the tape. And now how does it learn the input? Well, every time step it's fed one. It's a Turing machine where the input is on the tape and it reads it one character at a time and it can't move the head backwards. The head just moves once through the tape. Right?
Yeah.
So why do you need to know about those? Well, if you're an engineer and you're building a Coke machine, you need to know my Coke machine is in some state. I get some input from the world. I move and I do a state transition. I then go into a different state. Right? That's the way Coke machines work. Right?
Yeah.
You put in another quarter. I do a state transition. My input is I got a quarter. Now I change states to, well, now I know that the person has put more money into the machine state. And then they push the go button. Now I know I need to spew out a Coke. Right?
Professor,
State transitions. Yeah.
I read a little bit in your book, the How to Think About Algorithms book, and you mentioned like thinking about computation as like snapshots in the computer.
Yeah.
And I get that, but I'm not really sure like how that's supposed to change my idea of like how I'm supposed to think about things. Like I get you saying to think about stuff as states, but yeah, I don't know if you could just elaborate.
Yeah. So what I like to think about is if you're standing, we're in Toronto, so we have streetcars, come downtown and stand in a streetcar, or it's a subway, right? You're standing in the subway and you're explaining to your friend how an algorithm works, right? What do you say to your friend? You say the first thing we do is we set I equal to 0, right? Do you give him the first line of code and then give him the next line of code? Do you give him code as you're standing there in the subway?
No.
Absolutely not. Absolutely not, right? How do you describe the algorithm? The way I would do it, at least, is I would tell them the loop invariant. I would say, generally, when I'm at the top of the loop, this is the state I'm in. This is what the computer is remembering. This is what it knows. This is what the data structure is going to look like. This is where the head is, right? So basically, I'm describing to you the state of the Turing machine, right? It's if I were going to name the state, I would name the state Q for state. I don't know why Q is often used for state. And then the name of it would say, oh, I know I'm in line 5 of the code. I know this variable. I know this. It tells me what I know, right? So I would tell, standing in the subway, I would tell my friend, I would describe to them the state the computer is in when at the top of the loop. And then I wouldn't describe any code of the loop. I probably wouldn't. I would say, how do I transition from that state to what state I will be when I come around again, right? I'm in this state, I come around, now I'm in this state. I come around, now I'm in this state.
So I'm getting from like the way you wrote that book, I'm getting that's how you want us to describe stuff on the tests. Like you want us to think about it in that way, right?
When you're doing it, when you take 3101 from me, absolutely.
Okay.
Right? 3101, the first quarter of the course is what's the loop invariant? Can you describe to me what's true? What is the state the machine is in at the top of the loop? And all I need to know about the loop itself is that I'm somehow making progress and I'm somehow maintaining the loop invariant, right? And the code that does it, to me, is somewhat not the point.
So for this class though, you want us to be like detailed about what actually happens at the loop. And like later on in the next class, it's about talking about it abstractly.
No, actually, if you look at what I wrote down, where is it? I might be able to find it here, but remember we were in line 4. And what do I remember? I'm at the top of the loop, I'm on line 4. And then in just one, I did all of that action in one transition. We went from line 4 to line 4 to line 4 to line 4, right? And so maybe lots of actions happen during that loop, but it all gets expressed in what state am I in at the top of the loop, right? So it goes from 4 to 4 to 4 to 4 to, oh, I'm exiting. Now I'm at line 18, right? So in some ways, what the Turing machine, the Java code talked about all this nonsense in between, right? This action and this action, whole bunch of actions. But the Turing machine is, in some ways, is more like what I'm talking about in 3101. Because I'm telling you, I'm standing on the subway, I tell you what's true when I'm in line 4. And then I say, okay, and then we do a bunch of things, and then I will be in line 4 again, and this is what's true at line 4. And what happened from the one line to the other line 4? Well, I made some progress, so I had some measure of progress. And I maintained my loop invariant, right? I still have, this is the property that I have at the top of the loop. Right, does that make sense?
I guess what I was asking more was like how I can use this for this class specifically, like that thinking about everything that happens in snapshots and states.
Yeah.
But I get what you're saying about like all the Java stuff in between the loop.
Yeah, so I guess what is the take-home message from this insertion sort example is that what really matters is that I have a loop invariant, I express that loop invariant into my states and my where I know the head is, the loop invariant's expressed there, and then in every iteration of the loop, I know I'm making progress. Why? Because the head moves. In fact, that's the progress, is somehow your head moves. And I'm back up at the top of the loop, and so the loop invariant needs to be true, right? And so how am I thinking about this algorithm is I have the loop invariant, which tells me what state I'm in, and I go from state to state to state, right? That's what I'm maintaining. And I'm giving just slight lip service to actions in between. In fact, on the subway, I probably wouldn't, like, if I was describing insertion sort to you on the subway, what I would say is, I'm at the top of the loop. Some of the numbers have been sorted and they're over here. And the rest of the numbers are in a bucket over here. I haven't looked at them yet, right? So that's a picture. It says some numbers sorted over here, the rest are over here. And then I'm gonna say that somehow I do have to take an action to come around and maintain the loop invariant. Well, the measure of progress is how many numbers are over here. So I have to make that bigger. And I'd say, well, the way I maintain the loop invariant is I take some number from over here and I insert it where it belongs, right? And so I've made progress because my list is a little longer, and I maintain the loop invariant because the numbers over here are still sorted and I still have some numbers over here, right? So I did give you some sense of action. Take a number from here and sort it where it belongs. But I'm assuming that you're smart enough to figure out how to do those actions. And if on the subway, you respond by, Jeff, but I don't know how do you insert it where it belongs, right? Then I would go into more details on, okay, how do I insert it where it belongs? Well, there's an inner loop and I have to go around long and say, have I found where it belongs yet? And if it haven't found where it belongs, then I had to go one shift one over, and then I find the spot, and then I have to shift everybody over, right? I could describe, but that's more detail on actions. And again, I define that by doing another loop invariant, right? Right, does that make sense?
Yeah, that makes sense, thank you.
And in some ways, right? In some ways, this kind of comes up to, if I wanted to find something, right? What my loop invariant could be is I'm searching along, maybe I'm searching from this end, right? I'm searching and my loop invariant is that what I'm looking for, I haven't found yet. It's not to my right. Oh, no, my left. I lose my left and right, right? So how do you maintain the loop invariant? You say, well, if what I'm looking at isn't what I'm looking at, what I want, and I know what I'm looking for isn't to the left, so I move my head one to the right, and I've maintained the loop invariant that what I'm looking for isn't to the left. Why? Because it wasn't what I was at. I moved left, and that maintains the loop invariant, right? Now, the other case is, right? What I'm looking for from the loop invariant, I know what I'm looking for is to the left, and what I'm looking at is what I'm looking for, right? What do I do then? Well, then I celebrate because I found it, right? So it is kind of like, all I know is the loop invariant's true. I get some input from the world. Now, what actions do I take? Right? Does that make sense?